These next two type of problems are solved somewhat differently, and students definitely get confused between them. Notice that in number 14, I don't have an equal sign. So here I'm going to need to keep everything over a common denominator, show what the answer is as a fraction in the end, these three things combined over that common denominator. As opposed to number 15 does have an equal sign. When it has an equal sign, I have a very different goal. There I'm trying to isolate x, so it usually makes sense to try and get rid of all the fractions right away by multiplying by the common denominator. That said, even though we learn that later on, how to get rid of these fractions, I can apply that to things like 14. When we're talking about adding and subtracting with common denominators, the denominator must stay in the problem. So the first thing I want to do when I look at this problem is factor the bottom of this. I see a trinomial, I want to make sure I know what the actual factors are. So here I'm going to put x and x, bring down that negative, positive means same, so it's also negative. Multiplies to 2, adds to 3. Only one way to multiply to 2, 1 times 2. So 2 goes here, 1 goes here. If I now look at the other denominators, x minus 1 and x minus 2, well, if I multiply those two together, I would get exactly this. So if I want a common denominator, I just have to multiply by what's missing in these other two expressions. Here I have the x minus 1, but I don't have the x minus 2. So I'm going to multiply by x minus 2 over x minus 2. Here I have the x minus 2, but I don't have the x minus 1. So I'm going to multiply by x minus 1 over x minus 1. Taking it term by term, this 8x stays just how it was, still over x minus 2, x minus 1. I'm then adding to that 8x times x minus 2. 8x times x gives me 8x squared. 8x times negative 2 gives me negative 16x. This is now also over x minus 2, x minus 1. Finally, I need to make sure this negative stays attached to the 4x when I multiply. So it's going to become negative 4x times x is negative 4x squared, and negative 4x times negative 1 is positive 4x. So really I'm adding this once I've distributed that negative to the numerator, and on bottom I have the same x minus 2, x minus 1. Final step is combine like terms on the top and leave it all over this x minus 2, x minus 1. So here I have positive 8x squared, here I have negative 4x squared. 8 minus 4 leaves me with positive 4x squared. Here I have 8x minus 16x gives me negative 8x. Negative 8x plus 4x gives me negative 4x. When I look at that top, I realize that I can take a 4x out of that top. If I take the 4x out, I'm left with x minus 1. This is already one of the choices on bottom as a factor. So I can cancel those and leave myself with just 4x over x minus 2. For problem 15, again, we're going to approach it a little differently because of this equal sign. When I'm trying to solve and that equal sign's in the equation, my goal is I don't want any more fractions in the problem. So what I'm going to do is take 2, 4, and 9 and see what the least common multiple of these are. If I do my list for 2, I would go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. For 4, I'd go 4, 8, 12, 16, 20. For 9, I'd go 9, 18, 27, 36, 45. I don't have any number that's on all these lists. So I would have to keep going, or I'd have to recognize 36 is the number that's going to be on each of these lists first. Not sure the best way to tell you how to recognize that. I would say that basically you know that it's between 4 and 9. If you wrote out the list for 4 and 9, they don't share any common factors, so you multiply them by each other. In the end, if I can recognize that 36 is the least common multiple between these, then my goal is to multiply each term by that 36. Worst case scenario, you could always multiply these three together. If you multiplied all three of them together, you'd actually get to 72. So you'd be making it a little more complicated, but it would still get you to the right answer. You'd just be dividing by bigger numbers down the line. The reason we multiply here is to get rid of fractions. This 9 and this 36 reduce, and say that I'm multiplying by 4. This 4 and this 36 reduce, and say I'm multiplying by 9. And this 2 and this 36 reduce, and say I'm multiplying by 18. So let me do out each of these multiplications. 4 times 2x gives me 8x. 4 times negative 1 gives me negative 4. Negative 9 times x gives me negative 9x. Negative 9 times 2 gives me negative 18. 18 times 2 gives me 36x. 18 times 7 gives me 70 plus 56, 126. My goal is now get all the x's to one side, get all the numbers to the other. So I'm going to take x's over there with the 36. Or you know what? No, let's take x's over to this side. Let me think about that. Let's take x's over here so they're positive. Add 9x, subtract 8x, subtract 126. Add 9x, subtract 8x, and subtract 126. 36 plus 9 is 45. 45 minus 8 is 37x. On this side, negative 126 minus 4 is negative 130. Negative 130 minus 18 is negative 148. If I divide both sides by the 37 in front of the x, I probably am going to need a calculator for this. Hopefully I didn't make a mistake as I went along, because these numbers do look a little weird. But if I take 148 divided by 37, it gives me exactly 4. So that tells me that x equals negative 4.